In this video, I want us to talk about oxidation state, or what we normally refer to as oxidation number. In simple terms, oxidation state reflects or shows the number of electrons that an atom has lost or gained compared to its neutral state. Now, there are few rules for assigning oxidation numbers. Let's take, for example, chlorine. Chlorine is a neutral molecule, and the rule says the oxidation state of elements in their elemental form is 0. In simple terms, what I'm saying is that the oxidation state of an individual atom in a free element is 0. Hence why the oxidation state of chlorine is 0. Now, second example, we have lithium hydride. Lithium belongs to group 1. That means it has one valence electron that it has to lose to achieve the noble gas configuration. Remember that when atoms loses electrons, they become positively charged. Hence why the oxidation state of lithium is +1. The question is, what is the oxidation state of hydrogen in this case? The rule says the oxidation state of hydrogen when bonded to metals is always -1. Hear me out. We know that when hydrogen is bonded to non-metals, the oxidation state is +1. But in this case here, because the hydrogen is bonded to a metal, that is lithium, its oxidation state is going to be -1. The third example, we have magnesium bromide. Magnesium belongs to group 2. That means it has 2 valence electrons that it has to lose to achieve the noble gas configuration. Hence why the oxidation state of magnesium in this case is +2. And that of the bromine is going to be -1. Why? The rule says in binary compounds with metals. That means when group 7 elements are bonded to metals, they have an oxidation state of -1. When group 6 elements are bonded to metals, they have an oxidation state of -2. And when group 5 elements are bonded to metals, they have an oxidation state of -3. Now, example number 4, we have permanganate iron. The oxidation state of the iron is -1. The rule says the oxidation state of an iron is equal to the charge on the iron. And as for the fifth example, we have sulfur hexafluoride. Now, hear me out. The oxidation state of fluorine is always -1. In its compounds, the oxidation state of fluorine is always -1. Example number 6, we have magnetite. And we are saying that the oxidation state of iron is +8/3. Why? How did we get that 8/3? We don't know the charge of iron in this case. So we are going to let X be the charge of the iron, right? And we have 3 iron atoms, right? So that's going to be 3 times X plus 4 oxide ions times the charge of the oxidation state of the oxide ion, right? Remember that the oxidation state of an oxide ion is -2. So that's going to be 3x plus 4 times -2 is equals to 0. 0 being the overall charge of the magnetite. Remember, the magnetite is a neutral molecule, and the oxidation state of a neutral molecule is 0. So that's going to be 3x minus 8 is equals to 0, right? Trying to get x here. So x becomes 8/3. So the oxidation state of iron in this case is +8/3. Now, the last example, we have the permanganate ion, right? We said the charge or the overall charge of the permanganate ion is -1, right? That is to say the oxidation state of all the atoms is equals to -1. So the overall charge is -1. The question is, what is the oxidation state of manganese? The oxidation state of manganese is +7. How did we find that 7? Simple. We are going to let X be the charge of manganese, right? Plus 4 oxide ions times the charge or the oxidation state of the oxide ion, that is -2. So that's going to be X plus 4 times -2 is equals to the overall charge, which is -1. Remember that we said the oxidation state of an ion is equal to the charge on the ion, right? Trying to solve for X, that's going to be X minus 8 is equals to -1. And X becomes -1 plus 8, which is +7. Ladies and gentlemen, thank you.